reality feels obvious. The world seems to exist on its own, solid, stable, independent of us. Mountains don't disappear when no one looks at them. Stars keep shining whether anyone is watching or not. The universe feels like something that simply is. But what if this feeling is misleading? What if reality is not an independent thing at all? What if the universe does not exist by itself in the way we instinctively believe? This question sounds philosophical, but it didn't come from philosophy. It came from physics, from the deepest attempts to understand what the universe is actually made of. For most of human history, reality was assumed to be objective and independent. Ancient thinkers imagined the universe as a stage where events unfold, whether anyone is present or not. Classical physics reinforced this idea. Objects had positions. Forces acted locally. Time flowed uniformly. The universe existed as a complete structure, indifferent to observers. This worldview worked remarkably well until physics went deeper. When scientists began probing reality at its most fundamental level, something strange happened. The idea of an independent, self-existing world started to crack. Not metaphorically, mathematically. Quantum physics did not simply reveal new particles. It challenged the very idea that reality has definite properties on its own. At the quantum level, systems are not described by concrete states, but by probabilities. A particle does not possess a single, fixed set of attributes. Instead, it is defined by a range of possible outcomes. These possibilities are not just unknown, they are genuinely undefined until interaction occurs. This means that reality, at its foundation, is not a collection of fully formed things. It is a set of potential relationships. That alone raises a disturbing question. Can something truly exist independently if its properties are not fully defined? In classical reality, independence means completeness. An object exists with or without interaction. Its properties are intrinsic. But quantum systems don't behave this way. Their properties emerge through interaction. Without interaction, there is no concrete state, only possibility. This suggests that independence, as we usually imagine it, may not exist at the fundamental level. Another clue comes from the structure of physical laws themselves. Modern physics does not describe what things are. It describes how information about systems changes. The equations don't talk about solid objects. They talk about probabilities, correlations, and transitions. This shift is subtle but profound. Physics no longer describes reality as a collection of independent entities. It describes reality as a network of relationships. In such a network, nothing exists in isolation. Everything is defined relative to something else. This becomes even more unsettling when we consider space and time. We tend to think of space as a container, an empty stage where reality unfolds. But several modern theories suggest that space itself may not be fundamental. Instead, space could emerge from deeper, non-spatial structures. If space is emergent, then separation is not fundamental either. Distance becomes a secondary concept, derived from more basic relationships. Reality becomes relational, not spatial. Time may be the same. At the deepest levels, physical laws do not clearly distinguish past, present, and future. The equations often work just as well forward as backward. The flow of time, the sense of now moving forward, appears to be something that emerges, not something built into reality. If space and time are not fundamental, then what is? Many physicists now believe that the most basic ingredient of reality is information. Not information in the everyday sense of facts or data, but information as structure distinctions, correlations, patterns. In this view, reality is not made of matter sitting in space over time. Reality is made of relationships encoded as information. Matter, space, and time emerge from how that information is organized. This radically changes the meaning of independence. If reality is information-based, then nothing exists on its own. Information only has meaning in relation to other information. A single bit means nothing without a system that distinguishes it. Reality becomes something that exists through interactions, not apart from them. This does not mean reality is an illusion. It means reality is not a static object. It is an ongoing process. Think of a story. A story does not exist as a single object. It exists through relationships between events, characters, and meanings. Remove the relationships, and the story disappears. Reality may be similar, not a thing, but a structured process unfolding through interaction. This perspective helps resolve several long-standing mysteries in physics. For example, it explains why quantum systems behave differently when isolated versus when interacting. Isolation is not a natural state. Interaction is fundamental. Without interaction, there is no fully defined reality. It also explains why attempts to describe the universe as a collection of independent building blocks keep failing. The universe resists being reduced to separate parts. Its behavior depends on the whole. Even gravity seems to fit this picture. Some modern approaches suggest gravity is not a fundamental force at all, but an emergent effect arising from changes in information and structure. If this is true, then reality is deeply interconnected at every level. Independence is not the rule. Relationship is. But this raises a disturbing implication. If reality is not independent, then what does it depend on? The answer is not simple, and physicists do not fully agree. Some argue that reality depends on interaction itself, that existence is defined through mutual influence. Others suggest that reality depends on consistency, that only structures that can maintain coherent relationships persist. There is also the idea that the universe is self-consistent, that reality exists because it is internally coherent. In this view, the universe does not need an external foundation. It exists because its structure allows it to exist. This sounds abstract, but it has practical consequences. If reality is not independent, then certainty becomes impossible at the deepest level. There are no absolute facts detached from context. There are only facts within frameworks, relationships, and interactions. This does not weaken science. It strengthens it. Science becomes the study of patterns and relationships, not the search for ultimate objects. It also changes how we see ourselves. If reality is relational, then we are not outsiders looking at the universe. We are part of the process that defines it. Our existence is woven into the same network of relationships that produces stars and galaxies. This does not mean the universe revolves around us. It means we are not separate from it. We are expressions of the same underlying structure. Our thoughts, decisions, and actions are information processes embedded in a larger informational system. We do not stand apart from reality. We participate in it. This perspective can feel unsettling. It challenges the comforting idea of a solid, objective world that exists independently of everything else. But it also offers something profound. It suggests that reality is not cold or indifferent. It is dynamic, interconnected, and meaningful through relationship. Existence is not about isolated being. It is about connection. The universe is not a finished object. It is an unfolding process. And that may be why it is possible to understand it at all. Because we are not strangers to reality. We are part of the same structure that gives it form. So, is reality independent? Quantum physics suggests the answer is no, not in the way we once believed. Reality does not exist as a static thing standing apart from everything else. It exists as a network of relationships, constantly forming, updating, and evolving. Independence is an illusion born from scale and habit. At the deepest level, reality exists only through connection. And that may be the most fundamental truth physics has revealed so far.